This is the window that you'll see when you first open LTspice. To start making a new circuit, I'll begin a new schematic. I can place my components anywhere in this area. I'll begin by making a simple voltage divider circuit. To place a resistor, I'll select the resistor icon on the toolbar and I'll click anywhere to place it. To get rid of this cursor, I'll right click. Alternatively, I can also use keyboard shortcuts. I can press R to place a resistor. You can see all the keyboard shortcuts if you go to Tools and Control Panel to Drafting Options and Hotkeys. Here you can see and change the hotkeys if you wish. To zoom in and out, I can use the mouse wheel, and if I press the space bar, my schematic will fit the window. I can also go to View and Show Grid to turn on the grid so I can place my components more precisely. Now I need to place a voltage source. And for that, I'll go to this icon which says Component. Here you can see the different components that are available in the LTspice library. I'll select a voltage source and place it. I'll connect these components using a wire. Now you can either connect them by going point to point, or you can go through these components like this and LTspice will connect them for you. Now I need to connect a ground. So every circuit has to have a ground. So this one, and all the voltages are referenced according to this ground. Before I simulate the circuit, I need to assign values to the different components. And for that, I'll right click on the voltage source and I'll type 10 volts. So I need to type the numeric value only. And I'll right click on the resistor and I'll type 1K. So K stands for a kilo or 1,000. So if I need a milli ohm, I'll type M, and U for micro, N for nano, and so on. I'll keep the other resistor as 1K also. I can place comments on the schematic if I choose this option, text, and this is useful when you have a large circuit and you want to name some area by a comment. So to simulate the circuit, I'll click on the running man here, and you can see the different options that are available, like transient, AC analysis, DC sweep. For now, I'll stay in the transient tab and I'll keep the stop time as 1 second. I'll keep the other items blank. So now I get a new window, that is the waveform window. And I can also see something written here that's .tran1. So this is called a spice directive, and it shows that I'm running a transient analysis for 1 second. If I hover over any node, I can see the cursor changes to a voltage probe. If I click on the input node, I can see the input voltage on the waveform window. I can change this axis by right-clicking on it. So I can change the top value and the bottom value and the middle ticks also. So if I click on the name of the trace, I'll get a cursor. I can drag this cursor and I can see the precise value at whatever time instant that I want. I can click here at this point on the schematic to see the output voltage, and I see the output voltage, which is the voltage of node 2 is 5 volts. So the voltage divider circuit is working. Sometimes it is useful to have different labels for different nodes. I can select the label icon here, label net, and I can type output. Then I can connect it to this node. So if I run it again, and notice that I did not have to specify how long I need to run because the spice directive is already here. So I can see this voltage now, it says V output. Now to measure any current, I can hover over any component and I can see the cursor changes to a current probe. And the current probe also shows the current direction, which is the convention that LTspice has made for this current. So if I click on it, I can see the current that is flowing through this component, that is 5 milliamps. Again, I can change this axis also. And if I double click on any node or any current, I'll see that trace only, and all the other traces will be removed. If I right click on any trace, I can change the color and the expression. So this expression, I can scale it by any factor. So if I multiply it by 2, I'll see the current has changed to 10 amperes. I can even add or subtract other traces or even multiply other traces. For example, if I multiply this by V output, so basically I'm getting the power that is dissipated in this resistor R2. So that's 25 milliwatt. An easier way to find the power is to hold the Alt key on the keyboard. Now if I hover on any component, I can see the cursor change to a thermometer. If I click it while holding the Alt key, I'll see the power dissipated in this resistor. I can check the power that is dissipated in R1 also. So it's the same. And I can check the power that is going through the source, and that is minus 50 milliwatt. So the minus is because of the current convention and because the source is applying power, and as you can see, it is double the amount that is dissipated in the two resistors. Now all the voltages that I have been seeing until now are referenced with this ground. So if I need to see the voltage between 2 points, for example this resistor R1, what I can do is I click here and I hold on my click and I drag it around the resistor. So when I stop clicking or unclick, I can see the voltage across resistor R1. If I do it the other way around, meaning I start from here and I go around it, I can see the voltage is -5. Now I'll add a capacitor across the output by selecting this capacitor here. I'll connect it and I'll keep the value as 20U. So 20U is 20 microfarad. I don't have to write the farad, just the value. Now if I run, I'll see that there is no effect because there are no changing voltages here. So the capacitor is not having any effect here. But if I go to simulate and edit the simulation command, if I check this box that says start external DC supply voltages at 0 volt, now I can see the command has changed. There's a startup written right here. Now if I run it, I can see the voltage rises from 0 and goes to the final value. I can zoom in on this area by dragging across it. So if I click on the trace name, I can see the cursor and I can find how the voltage rises at different values. If I click the trace again, I'll see another cursor, so number 2. And now I can see the difference between these two cursors. So cursor 2 minus cursor 1, I can see the vertical distance. So this distance, that is 1.15 volt here, and the horizontal distance. I can also see the slope and the frequency. So this was a basic example on how to use LTspice.